We continue presenting the calculus menu in the wxMaxima interface, following up from where we left in the last video, and that's in this document. We're going to start with differentiation, differentiate calculus of derivatives. If we use calculus differentiate, we get an entry form. We can replace our expression to take the derivative with respect to, select our derivation variable, and indicate how many times that we're going to take that derivative. In this case, we are doing one derivative, we get this result. The differentiate box triggers the command diff, that means differentiate. And when we do shift enter here, it tells me that derivative of x log of x minus square root of x is equal to this. Second example. In the second example, if you go calculus differentiate, you can type the expression here, x times log of x minus square root of x, and we're going to do the differentiation 3 times. You get this result. I'm going to cancel that, and that will be that third integral. As in the case of integrals, if you want to show your derivative without evaluation, use an apostrophe and we'll give you the derivative, and then use evaluation percentage nouns to give you the result of the derivative. The second example here for the third derivative will give you first the unevaluated derivative and then the result of the evaluation. So the derivatives are straightforward, and you can just type the command diff, and let's say you have, I'm going to change the variable to s. I'm going to find the derivative of the log of x. Remember, log of s, log is the natural log. You get 1 over s. Find limit. That's calculation of a limit, and there's the classical limit I use as an example here. You go find limit. You put sine of x divided by x around 0 from both sides. You can select the left side, the right side, and so on, and press OK, and you get that the limit is equal to 0. I'm going to delete that result because I have it right here. If you do shift enter, that gives you that the limit is equal to 0. Limit from the left, you have to select in the form there that you're coming from the left, and all what it does is to the limit command is add the word minus. I mean, you're coming from the left, and if you're coming from the right, add the word plus. A limit to infinity and a special limit. You go for the calculus find limit form, enter the expression to find the limit, the point where you're going to find the limit, and then change this to special, and I'm going to go for minus infinity or plus infinity, pi or e are the 4 options. Let's go to infinity. That changes to the word inf, and we're ready to do it right there, and that limit is equal to 0. That's the result that I got here. Using Taylor series, this I suppose expands the function to Taylor series before you take the limit. So the example I have right here produces the word t limit. That means Taylor series limit of sine of x. In that case, I put pi over 3 at the point of the limit and do shift enter, and they give me a square root of 3 over 2. And so, and the next example, we're going to work about finding minimum. When you try to find a minimum of a function, what you want to do is insert here find minimum, type the expression that you want to find the minimum to, like in this case is 2 times x squared plus x minus 1. The variable of the independent variable, initial estimate for the minimum, I put 1 as the default value. Let's try 2. And epsilon is the error allowed in the finding a minimum. When you say OK, you get this LFBGS, and there's a 4th argument here that's not specified in the form, and that's just the range And that range seems to be selected arbitrarily, but if you don't find your result in that range, you can change it. You can change that range. So I'm going to delete this. My original version was a guess of 1, and I need it come out as minus 5.25. If I had something like 0, say 0 to 5 here, and I try to find it, it gives me a lot of information there. Basically, we're saying that range is not good, and so you have to play with that. And let's say minus 10 to 0, and that give me a result. So you have the option of playing with the numbers after you enter your command. Continue now with the option Get Series in the menu. And that wants to expand a function in a Taylor series or Maclaurin series. That's when the point of expansion is 0. And so we go for Calculus, Get Series, and say we're expanding the series for sine of x raised to the square, and we're going to expand it around the point pi over 2. The depth indicates how many exponents or terms are going to have. Let's raise this to 10, and let's say OK. And so it shows that if I include up to the 10th power, my series is going to look like this, with the these 3 dots indicating that the series continues. All right, so that's the example I just did right now. The original version with 8 will have given me this result. You can type it instead of going through the form. For example, the Taylor series for log of x around 1 with 10 power series 10 will give me that. Now in the options, you can select power series, and what it does, it tries to give you an infinite sum. And so let me, well, you know how to do it here. You simply go to Calculus, Get Series, and type the values there, log x. No, let's do it, log x, x about 0.1. And now we select power series. The depth doesn't matter. And what we get is this command called nice indices, power series of log of x, and so on. And it tells me this is equal to minus the summation from I equal to 1 to infinity, the minus 1 to the I, x minus I, and so over I. So it gives you like the symbolic total expansion of the series for these particular conditions. I'm going to delete that because I have it right here. It's the same thing as that. The next one is called Padé Approximations. And so this is another subject that I'm not very familiar with, but you can find information on that. The approximant is a fraction. It's a fraction where there are 2 polynomials, one in the numerator, one in the denominator. And so, for example, if you expand a Taylor series already, like this one, okay, and you want to find the Padé approximation, you go Calculus, Padé approximation. For the previous result, the degree of the numerator will be 10, the degree of the denominator will be 4. It tells you Padé 10, 4, and it gives you 3 possible options of Padé approximations that represent the Taylor series expansion. I'm going to eliminate that from here, repeat it here, and this time we're going to end up the presentation of the second part for the calculus menu.